Welcome back, everyone. In our last discussion, we got a big picture view of environmental impact assessments. Today, we're going to zoom in and do a real deep dive on the very first and, you could argue, the most critical step in that whole process, screening.
We're going to cover what EIA screening is, its methodologies, frameworks, and technical criteria, and then its practical application through the mitigation hierarchy, potential outcomes, and common pitfalls. Let's begin unpacking each of these critical components. So let's start with a classic scenario. Imagine a big new project is being proposed nearby. Maybe it's a factory or a huge new wind farm. The immediate question is, does this thing automatically need a massive, months-long, and super expensive environmental review? Or is there a smarter way to figure this out? Well, that's precisely the problem that screening is built to solve. So what is EIA screening? You can think of it as the first major decision point in the entire EIA journey. Its whole purpose is to answer one single fundamental question. Does this particular project really need a full environmental impact assessment? Okay, so if we get technical, the official definition of screening is the process used to determine if an EIA is necessary for a proposed development. It's essentially a preliminary check, a first filter that every single project has to go through. And this happens really early on, right at the beginning, so that everybody involved knows exactly what they're getting into. I like to think of screening as the gatekeeper of the whole EIA process. It has two incredibly important jobs. On one hand, it stops projects that will have very little environmental impact from getting totally bogged down in paperwork and delays. That saves everyone time and money. But on the other hand, it makes absolutely sure that projects with potentially huge impacts are flagged for the serious, in-depth investigation they demand. It's really all about using our resources wisely, focusing the heavy-duty analysis where it's needed most. So, how is this big decision actually made? It's definitely not just a random guess. There's a whole toolkit of methods that authorities use to make a call that is both consistent and defensible. Let's open up that toolkit and see what's inside. Now, when you look at screening systems across the globe, they tend to follow one of two big ideas. First, you've got the prescriptive approach. The best way to think about this is like a really strict black and white rulebook. It uses fixed criteria. There might be a list of projects, say a nuclear power plant, that always needs an EIA. No questions asked. Or maybe there's a size threshold. Any factory that produces over a certain amount automatically triggers an EIA. The big plus here is that it's clear, consistent, and pretty fast. But then, on the other side, you have the discretionary approach. This is much more like a detective's investigation. Instead of rigid rules, it relies on guidelines and the professional judgment of experienced assessors. They look at each project case by case, which gives them a lot more flexibility to consider the specific location or the technology being used. Of course, it can take more time, but you often get a much more tailored decision. In reality, a lot of modern systems use a mix of both. So let's look at the specific tools that bring those approaches to life. The simplest are lists. A positive list, for instance, says that certain high-impact projects, think oil refineries, are automatically in for a full EIA. A negative list does the opposite, exempting projects with virtually no impact, like, say, minor building repairs. Then we have thresholds. These are all about numbers. An EIA might be required only if a project is over a certain size, like a new housing development with more than 500 homes. The danger here, of course, is that developers might design their projects to come in just under that number to avoid an assessment. Criteria-based screening is more nuanced. It's often a detailed checklist that guides an assessor through things like a project's location near a national park or its potential to pollute. Matrices are a great visual tool for this. Imagine a grid where you map out project activities against environmental factors to see where they might clash. And finally, if there's still some doubt, an authority might ask for an initial environmental evaluation, or IEE. It's like a mini EIA, just enough to figure out if the full resource-heavy process is really necessary. So, how does this all work on a global scale? Well, as you can imagine, with so much international development, major funders like the World Bank needed a consistent way to handle this. So, they created standardized screening frameworks. The goal was to make sure that any project they financed, no matter where it was in the world, would meet a certain level of environmental care. This has created a reliable benchmark for responsible development everywhere. And this quote right here really gets to the heart of it. The whole point of this process, starting with screening, is to be proactive. It's not about punishing people or cleaning up a mess after the damage is done. It's about having the foresight to build environmental and social thinking right into the DNA of a project from day one. It's about designing out problems before they ever happen to protect both nature and people for the long haul. Now, the World Bank's model is probably the most influential framework out there, and lots of countries have copied it. It's a really smart, tiered system that sorts projects by risk. So at the very top, you have Category A, This is for projects that could have significant, widespread, or even irreversible impacts. For these, a full EIA is absolutely mandatory. In the middle is Category B. These are projects whose impacts are less severe, usually contained to an area, and can be fixed with known solutions. They still need some environmental analysis, just not the full-blown EIA. And finally, there's Category C, which is basically the green light. These are projects with little to no environmental impact, so after screening, they're good to go. So what does it take to land a project in that high-risk Category A? Well, it all comes down to the kind of harm it might cause. An impact is considered sensitive if it affects something fragile, like a coral reef or an indigenous community's sacred land. It's diverse if it doesn't just harm one thing, but hits the air, the water, and local wildlife all at once. An impact is irreversible when the damage can never be undone, like causing a local species to go extinct. And finally, an impact is seen as unprecedented if the project is using some brand new, untested technology or if it's being built in a pristine wilderness area. Any one of these flags signals a high risk that demands the most serious level of assessment. Category B and C projects, on the other hand, are just on a different level. For Category B, think of something like upgrading an existing road. Yes, there might be some soil erosion during construction, but it's localized. We know how to deal with it, and we can manage it with standard practices. Category C projects are even simpler because they often don't involve any major construction at all. These are your soft projects, things like developing a new school curriculum or funding a public health program. Their main impact is social, not physical. But here's the thing. Even with all these categories and lists, screening is rarely just a simple box-ticking exercise. The rules provide the structure, sure, but the final call often comes down to a really nuanced technical evaluation. And this is where the experience and professional judgment of seasoned environmental experts becomes so incredibly important. They're the ones who have to interpret the data and make a solid, defensible decision. So, what exactly are these experts weighing? Well, first is the sheer size and scale of the project. Not just how much land it takes up, but how much water it's going to use or how much waste it's going to create. Just as important is its proximity to sensitive receptors. A small factory in the middle of an industrial park is one thing. That same factory right next to a school or a nature reserve is a completely different story. They also have to dig into the nature of the project itself. What kind of chemicals are being used? What's the risk of an accident? Then, of course, there are the direct ecological impacts. Is this new highway going to slice a forest in two, cutting off wildlife? And finally, they have to consider one of the trickiest things of all, cumulative impacts. This is the straw that breaks the camel's back problem. One small project might seem fine, but what if it's the 10th small project in the same valley? At what point do all those small impacts add up to one big disaster? It means you have to look beyond the project itself to the bigger picture. Now, there's a really important guiding principle that sits behind this whole process, and it's called the Mitigation Hierarchy. Honestly, this idea is more than just a tool for EIA. It's become a cornerstone of modern environmental management all over the world. It gives us a clear, structured way to think about how to deal with any potential environmental harm. And at its core, it's an idea we all understand instinctively. Prevention is always better than cure. It just makes more sense, financially, ethically, you name it, to avoid causing damage in the first place rather than trying to fix it or pay for it later. The mitigation hierarchy simply takes that common sense idea and turns it into a formal process. So here's how it works, and the order is incredibly important. The first, highest, absolute priority is to avoid the impact completely. Can we move the road so it goes around the wetland instead of through it? Can we use a different technology that doesn't produce toxic waste? Only if you absolutely cannot avoid the impact do you move to step 2, minimize. Okay, we have to cross the river, but can we build a bridge with a smaller footprint to reduce the damage? Then, if there's still some harm done, the third step is to restore. After we're done, we have to go back and fix what we've damaged, replant native trees, for example. And only, and I mean only, as a last resort, when you've done all that and there's still significant damage left over, do you turn to compensate, which is also called offsetting. This is where you might try to create a new habitat somewhere else to make up for what was lost. It's the least preferred option because you're admitting that at the project site, there's been a net loss. So after going through all these steps and applying these principles, the screening process ends with a formal decision. And frankly, how well a developer can show they've followed that mitigation hierarchy can really influence the outcome. So let's look at what those final decisions can be and what happens next. At the end of the day, there are really 4 possible verdicts that can come out of screening. The first is that a full EIA is required. This is the most rigorous path. Second, for projects with less serious impacts, the decision might be that only a limited EIA is needed.
The third, and for the developer, the best case scenario, is that no EIA is required and the project can move forward. And finally, if there just isn't enough information to make a call, the outcome can be a requirement for further study, that IEE we talked about, to get the answers needed for a final decision. So, what happens when the decision is yes, an EIA is needed? Well, the process moves immediately into the next phase, which is called scoping. And it's a perfect name for it. If screening answers the question, do we need an EIA? Then scoping answers the question, okay, so what exactly should this EIA study? Think of it like creating the blueprint for the entire investigation. It's all about focusing the time, money, and expertise on the issues that matter most, making sure the EIA is efficient and effective. Of course, none of this happens in a perfect world. This process is run by real people in real agencies who are often under a lot of pressure. So for our final section, let's get practical. Let's look at some of the common problems that pop up during screening and talk about the strategies that experienced professionals use to handle them. One of the biggest issues is just a lack of resources. Not enough time, not enough staff. A smart way to deal with this is to use a hybrid approach. Use clear thresholds to quickly screen the easy projects, which frees up your experts to focus on the more complicated ones. Another problem is when the regulations themselves aren't very clear. When that happens, you really have to rely on the professional judgment of your senior staff. What about when you're faced with uncertainty, maybe because the project design isn't finalized? Well, one of the best things you can do is engage the public early. Local communities often have an incredible amount of knowledge that can fill in the gaps. And finally, there's the classic problem of reports filled with technical jargon that nobody can understand. The solution is simple. Commit to clear communication. Every decision needs a plain language summary so that everyone, not just the experts, can understand what's going on. And that leads us to a final thought to leave you with. As we've seen, screening is the gatekeeper. The entire EIA process rests on how well it's done. But in a world that's facing huge challenges, climate change, biodiversity loss, and massive complex new projects, we have to ask ourselves, how does this first critical step need to change? How must it evolve to meet the challenges of the future and continue to be an effective safeguard for our environment? If you found this breakdown of screening useful, please be sure to follow our channel. We would love to hear your thoughts and questions, so please share them in the comments below. Thanks so much for watching.